Hi. Okay. Let's move on to our last English presentation for today. So today we have TienVu, who came all the way from Singapore. He's currently working with for Lucasfilms, Star Wars, Indiana Jones, right? So today he's going to talk about algorithms and data structures in Python. Okay, on to you.
Hello everybody, my name is TienVu and I'm currently a developer in Singapore. So a little bit about me. So I start using Python about 1 year ago. So before I was a graphics programmer doing C++, CUDA and mobile games dev. So 1 year ago I picked up Python and I think it was a really cool language, beautiful syntax, and got a lot of cool tricks. So now I have completely moved to Python and learning web development. So you can find some of my project in my GitHub, and including this presentation. Just in case if you think I'm not making sense or want to add in anything, you can feel free to fork it and or add an issue. So first thing about Python is readability. That's one really cool things about it, and it's very important. Okay, let's start with some simple sorting algorithms. So anyone figure out what sorting algorithm is it? Say again. Quicksort? Yep, it's correct. And sorry, why is the screen is a bit small here? Yeah, this is how you do quicksort in Python, and below is the pseudocode. So you can see it, the pseudocode and the Python code look kind of, like more or less the same. So you don't even need to understand Python to know this is quicksort. It's really intuitive and self-explains. So that's a cool thing. But if you are a Python developer, then you might realize there's some problem with this simple sort algorithms, which is you have to generate two lists here, and you might think it's not very efficient. So instead of that, let's try to do something smarter. So we will do in-place sorting. Instead of generating two lists, you just sort it inside the existing list. You modify it, and it's a bit more complicated. And well, you may think it's faster, yeah, in theory. So let's do some quick experiments. So we have the simple quicksort here, and the in-place sort here. Let's try to run some tests and see which one is faster. Okay. So you can see it's more or less the same. So let's try one more time. And so you can see the simple quicksort is sometimes even faster. So a lot of times it is faster. Okay, great. So let's look at the code again and try some profiling to see what happened here. So that's a great tool called Live Profiler. So you can just do py install Live Profiler and decorate your function you want to profile with that here. So with that, just let's run it again. Let's just run only one time. So it's a bit slower because it's collecting on the statistic. Okay, so you can see in the first algorithms, most of the time is spent on these two lines. And for the second one, most of the time is spent on these for loops. So here the bottleneck is at the for loop, and here the bottleneck is at these two list comprehension. But you can see the time for the list comprehension is much more smaller compared to the whole for loop here. So the reason why this happened is because list comprehension is optimized in Python, so it doesn't have the overhead of doing for loops, so it's faster. It's the same as you do map or filter, because those operations are written in C, so it's faster than you do all this. Yeah, here there's no way to use list comprehension, or because you have to swap the list. So our smart approach actually kind of backfires. So the lesson learned here is simple is sometimes better. Okay. So, any question on that? Okay, let's move on. So in Python there are, I think, some fundamentals data types that I use a lot, which is list, dictionary, string, and set. So those are the basic data types. And for list, it's implemented using a dynamic size array. What does it mean? So let's look at the code. And this is implemented in C, so it's for speed. So the first thing you can see here is list resize operation. So in the dynamic size array, you allocate memory for the array, and then when you append or insert a new item to a list, you resize the array by doubling the space. And you can see here the space grows by 2 times. And therefore, operation like append pop takes only O1, and for index remove and insert, it takes a linear complexity. Let's look at the index. Okay. So here you can see it do a for loop and loop through all the elements of the list and return the match one. So the complexity is ON. Not really efficient. So be careful when you use insert or index. And one cool thing about list in Python is you can use it to implement a stack or queue, but a simple one. Why? Because if your programs use multi-thread, then this is not a thread safe. Let's see. So to fix that problem, Python got a module called Q and DQ. Oh, sorry. Let's do a demo first. So if you have a list, this is how you implement a stack. Just pop something. Just you append to put it in the stack and pop to retrieve it. For a queue, we can do the same thing. And instead of pop at the right, you pop at the left. So, but the problem here is pop at 0. If you use pop alone, then the complexity is just a 1 because it's at the end of the list. But if you use pop 0, then when it pop the elements, it had to shift the array back 1 position. So this operation will take ON. So that's why it's a bad idea to use pop 0. So Python introduced a module called DICT, where you can push and pop at both ends with O1 complexity. So this implementation is using a doubly linked list. So it's better than using a list here. But anyway, list is a good approach. So it's very fast and I mean it's fast to implement. And now one more problem is I mentioned above is it's not thread safe. So you have to implement some kind of locking mechanism for it. So in Python, there's a module called Q, which is basically just a wrapper of the DQ data types and with some locking mechanism. So if you look at Q, then you can see it's import a DQ here. And it initialize with a Q, and this new mutex to lock, so that there's no race condition when multiple thread trying to write to the queue. And of course, the queue is implemented in C, so it's very fast. Okay, one more thing is list versus array. So in Python, you have a list and an array, and the difference between this is list can store arbitrary object, and while an array is a clean wrapper plus C, so it can only store some limited data types like byte or char. But the advantage of using an array is the memory usage can be more efficiently used because it's basically store data in continuous block. But for performance-wise, I have tested both, and I think there's not much real advantage gained by using array compared to list. So using list is, I think, is better because it's more flexible. Okay. Another data type in Python which is very useful is a dictionary. So a dictionary is implemented using a hash table, and all the insert, retrieve, and update takes O1, which is really awesome. So we have a DICT object here. It's an array, basically. So it starts with 8 elements, and it doubles once 2/3 of the arrays are full, so that it can maintain the O1 complexity here. So to handle collision is use technical open addressing. So in implementing hash table, you have two mechanisms for handling collision. One is chaining, which basically when you compute the hash value, and if you found there's already one there's already collision there, you just append it to the list. So you have an array of n bucket, and each bucket is a linked list, and you just keep adding to the linked list when you have a collision. Another technique is called open addressing, and basically instead of pushing to the end of the linked list, it just give for each element, it just hold one value. So if there's a collection, it will just go to the next the next empty array and put it there. So for that, there's also two technical linear probing. Basically, it just increase one and put it to the first empty bucket. Another technical random probing is instead of increasing one by one, it just choose a pseudo random index and then it put it there. It might sound slower, but in practice this is much faster. So Python used that random proppings. You can find more detail here. It explains the algorithms. So, yep. It's pretty cool. So the application of a dictionary in Python is usually used to represent some data or data scenario when you have unique entities like a graph, a trie, or with all the frequency of the characters inside the string. So you don't have to do something like you do a for loop and then for loop of the string and then increment one by one. So this is a quick way to do it. And if you look at the code of counter, you will see that basically this is just a subclass of DICT. So it instead of overwriting the value when you have two matching hash value, then it just add it to the count. So it's somehow similar to the data structure called multiset. And one of the operations that I use a lot is called most common. So after you create a counter, you can query the counter which key has the most frequencies, and you can query them. Say, give me the top K. So this will give you the top K character that appear most in this string. And how Python does it is it create a heap queue and push that. It initialize a heap queue, and it use a heap queue to query the most commons. So you can look at the heap queue also. So basically this heap queue is like a binary tree, and at one node, the value of the node will always greater or always lesser than its children. So one characteristic of the tree is the root will always the smallest, or largest. So if you want to query the most common, what you do is let's say you want to query the top k most common, then you do a for loop from 1 to k, and then you get the first elements and plug it from the trees. So that's how Python do it. I was quite surprised because initially I thought the heap queue should be implemented in C, but in the end it turns out that it's implemented in Python. So it's really cool. Okay, another cool trick is dynamic programming in Python. So dynamic programming is a class of problem in computer science. Basically, you have problems and you want to solve the problems. You divide it into substates, and you want to find a relationship between a state and and another state, and you divide the problem. You solve the problem for a small state, and then you build up. So to do dynamic programming in Python, there's a trick here is using a decorator. So this is a decorator class, and to use it, for example, we want to compute the n Fibonacci number, so we just decorate the function with our members class, and you just do a recursive call here, and this is much shorter than if you use a multi-dimensional array to store the result. So instead of storing the result in the array, you store it right inside the function. You can do the same thing too with the longest increasing subsequence. Sorry. So really handy. What another cool trick in Python is sorting. So in Java or C++, you want to sort two arbitrary object, you have to define a common class of this object, and you define a compare function, and then you can sort it. But in Python, you can put them into tuples, and you just sort the tuples. For example, like in this example. So you can sort by the index, or if you have a class student, then you can sort by its attributes. And by default, if you don't specify the key, then it will basically sort from the 0 index and to the first index and so on. You can also use a method called item getter, so that you don't have to specify the student here. And you can also specify a compare function as just like in Java or C++. But this one has been deprecated in Python 3, so you can only use it in Python 2, I think. So conclusion is you should always know how basic data types in Python works so that you can do optimization. And you have to keep it simple and short. And built-in data types are your friend, so use it instead of reinventing the wheel. And one more thing is you should do profiling before optimizing code so that you know which part of the code is slow and where you should put more effort in optimizing it. There's a lot of tools for that. So, and finally, if you want to improve your algorithm skill or just want to have some fun, then there's website. It's a bit small. Okay. There's a lot of websites that host puzzle or programming problems, so you can practice your algorithm skill. Yeah, that's it. Thank you very much. So, any question?
Yeah, do we have any questions? I have one then. So you say that you have only been using Python for a year?
Yes.
Right? Before that, did you know what data types were in programming?
Yeah, I used C++ and Java before.
I see. Okay.
But in Python, it's much more easier to write some data structure like.
Do you have for example, if it's someone who's totally new with not much real basic computer science knowledge on data structures, do you have any tips? How, where, or what should they read to understand data types in Python?
So in Python, it's pretty simple to get started. First is, let's say you want to write a hello world programs. All you need to do in Python is just fire up the interpreter and do a print or something. So in Java or C++, you have to do more than that. Like you have to declare a class or include a lot of library. So that's one cool thing about Python. It's easy to get started, and the syntax look very friendly. It's actually quite close to pseudocode. So it's really good to get started in Python.
So you just write them straight. Just actually try and write them and use the interpreter and stuff. So that's the fastest way to learn.
So yeah, it's fast to get your hand dirty, and if you want to try new feature or try a new data types, just go into the interpreter.
Okay, thanks. Any other questions? Okay then, I guess there's no more questions. Thank you. No.
Okay, did you check the quick sort random list, right? In your benchmark, did you try the worst case?
Yeah, no.
Which is fabricated?
Yeah, I know. I don't check the worst case because.
You should give it a try and see what happens.
I just want to try the random case.
Yeah, it's more like a suggestion than a question, but anyway.
The worst case, then the in-place sorting will be better.
Right. Thank you.
Okay. Any more questions? Okay, we good? Okay. Thanks.
Thank you very much.